Welcome to the DIY Honda Garage channel. Welcome to this detailed troubleshooting guide for the DTC P0365 CMP Sensor B circuit no signal, specifically designed for Honda Civic models from 2016 to 2021. This error code indicates that the powertrain control module, PCM, is not receiving a signal from the CMP Camshaft Position Sensor B. This sensor plays a crucial role in monitoring the position of the camshaft, which is essential for proper engine timing and performance. When the PCM does not receive a signal, it can lead to issues such as poor engine performance, increased emissions, and difficulty starting. It's important to carefully follow each troubleshooting step to accurately diagnose and resolve the problem. The DTC P0365 concerns the CMP Sensor B, which is vital for determining the camshaft's position relative to the crankshaft. This information is used by the powertrain control module, PCM, to manage engine timing effectively. In terms of physical location, this sensor is generally situated near the engine, often on the cylinder head, making it accessible for inspections and tests. The sensor generates a voltage signal that indicates the position of the camshaft. If the PCM does not receive this signal, it cannot accurately control engine timing, leading to performance issues. Understanding the role and location of this sensor is critical when diagnosing errors related to the DTC P0365. Several factors can contribute to the occurrence of DTC P0365. First, poor electrical connections can impede the signal from the CMP Sensor B to the PCM. This includes loose or corroded connectors that can interrupt the flow of electricity. Another possible cause is open or shorted wires in the sensor circuit, which may prevent the sensor signal from reaching the PCM. A faulty CMP Sensor B itself could also be the culprit, in which case it would need replacement. Lastly, a malfunctioning PCM can misinterpret the signals received, leading to the error code. Therefore, it is essential to thoroughly inspect these elements during the troubleshooting process. Recognizing the symptoms associated with DTC P0365 can significantly aid in diagnosing the issue. Commonly observed symptoms include poor engine performance, which may manifest as rough idling, stalling, or power loss during acceleration. Additionally, increased emissions can occur as the engine struggles to maintain proper fuel-air mixtures. Drivers may also notice difficulty starting the engine, as incorrect timing can lead to inefficient combustion. Lastly, the check engine light will likely be illuminated, alerting the driver to the underlying issue that warrants immediate attention. Being aware of these symptoms helps in pinpointing the problem swiftly. The first step in troubleshooting DTC P0365 involves verifying the problem. Start by turning the vehicle into the on mode, which powers the electronic systems without starting the engine. Next, use the HDS, or Honda Diagnostic System, to clear any existing DTCs. This is a critical step, as it resets the system and prepares for a fresh diagnostic. After clearing, start the engine and monitor for any pending or confirmed DTCs using the HDS. If DTC P0365 appears, it indicates that the failure is replicated, and you should proceed to the next step in the troubleshooting process. If it does not show, it may signal an intermittent failure worth checking further. In this step, you will focus on determining the possible failure area concerning the circuit. First, turn the vehicle off to ensure safety while working on the electrical components. Once powered down, disconnect the CMP Sensor B3P connector, which is essential for isolating the signal source from potential errors. After disconnecting, turn the vehicle back to the on mode to perform a voltage measurement between specified test points. This involves testing between the CMP Sensor B connector number 1 and body ground. If the voltage is around 5.0 volts, this indicates that the VCC2 line is functioning properly. which leads to subsequent steps in the troubleshooting guide. This step involves checking for an open wire in the VCC2 line, which is crucial for the CMP sensor's electrical integrity. Begin by turning off the vehicle to ensure safety during your checks. Utilize the HDS to jump the SCS line, which puts the system in a diagnostic mode. Wait for more than 1 minute before proceeding to disconnect the PCM connector E, ADP. Now, check for continuity between the CMP sensor B, 3P connector number 1, and the PCM connector E, number 1. 70. If you find continuity, this indicates that the VCC2 wire is operational. In this scenario, you should consult authorized service information related to the problem, or consider substituting with a known good PCM. If the error code disappears after a PCM substitution, it would confirm a faulty PCM, necessitating its replacement. In this step, focus on checking another potential failure area, specifically the CAM-EX line. Start with measuring the voltage while the vehicle is in on mode, and ensure the CMP sensor B connector remains disconnected. By measuring between the CMP sensor B connector number 3 and body ground, you should be looking for a voltage reading close to 5.0 volts. This reading will help determine if the CAM-EX line is functioning properly. If you get around 5.0 volts, it indicates that the circuit is intact, allowing you to proceed to the next troubleshooting step. Conversely, if the voltage is absent or significantly lower, you will need to go forward to further checks to identify any underlying issues. Now we turn our attention to a potential issue in the SG2 line. Measure the voltage between CMP sensor B, connector number 1 and number 2, while keeping the connector disconnected in the on mode. The aim here is to identify if the SG2 wire is functional. A normal reading should be around 5.0 volts. Getting a positive measurement indicates that this line is operational, which would allow for the next steps to potentially replace the CMP sensor B if no issues are found. If the voltage is not within expected limits, then the troubleshooting must progress to checking for any open wires that could be affecting the signal transmission. Step 6 requires an open wire check for the SG2 line to ensure its continuity and functionality. Begin by turning the vehicle off for safety. Utilize the HDS to jump the SCS line and wait over a minute to prepare the system for diagnostics. Disconnect the PCM connector E, ADP, to completely isolate the PCM from the circuit. The next task is to check for continuity between the CMP sensor B, 3P connector number 2, and the PCM connector E, number 78. If continuity is present, it confirms this wire is operational. If not, it reveals an open circuit in the SG2 wire, necessitating repairs to restore proper function. In this step, you'll perform a shorted wire check specifically for the CAM-EX line, which is critical to ensure proper signal flow. Begin by turning the vehicle off to ensure that no current is running through the electrical system during the check. After this, use the HDS to jump the SCS line, allowing for a diagnostic session. With the PCM connector E disconnected, check continuity between PCM connector E number 32 and body ground. If continuity is detected, it suggests a short in the CAM-EX wire exists and needs repairing. If there is no continuity, it indicates that this wire is not shorted, prompting you to move to the next step in the troubleshooting protocol. The final troubleshooting step focuses on performing an open wire check for the CAM-EX line. Ensure the vehicle remains in the off mode while you prepare to check continuity. The CMP sensor B, 3P connector, and PCM connector E must both be disconnected for this check. Using appropriate equipment, measure continuity between CMP sensor B, connector number 3, and PCM connector E, number 32. A successful continuity test indicates that the CAM-EX wire is functioning correctly. If the wire shows no continuity, then repairs are required to address an open in the CAM-EX wire between the PCM and CMP sensor B. After completing all the necessary repairs, it is crucial to verify that the issue has been resolved. This process starts with clearing any existing DTCs using the HDS. After clearing, conduct a thorough road test to ensure that the vehicle operates smoothly without any engine performance issues. During this test, keep an eye on the instrument cluster for the check engine light and monitor for any immediate re-triggering of DTC P0365. If the light remains off and the vehicle performs as expected, this indicates a successful repair. This step is essential to validate that the initial problem with the CMP sensor B circuit has been effectively addressed. Preventive maintenance is key to ensuring the longevity and proper functioning of your vehicle's components. Begin by regularly inspecting the wiring associated with the CMP sensor B for signs of wear, fraying, or other potential damage. This proactive approach can help prevent future DTC P0365 occurrences. Additionally, it is essential to maintain clean electrical connections. Corrosion, dirt, or moisture can significantly affect sensor performance, so keeping connections immaculate will promote reliable signal transmission. Lastly, regular checks of the CMP sensor itself can identify impending failures before they lead to significant engine performance issues. Establishing these maintenance practices will keep your Honda Civic in excellent running condition. In conclusion, understanding DTC P0365 and the role of the CMP sensor B is vital for maintaining your Honda Civic running optimally. Following a systematic troubleshooting approach helps identify the root cause effectively. Make sure to verify symptoms, check electrical connections, and test wiring thoroughly. Smart preventive maintenance can deter many issues before they arise. Being proactive not only enhances vehicle performance, but also extends the life of critical components. Remember, routine maintenance and diligent diagnostics are your best allies in automotive care. Please like and subscribe to the channel. See you next time.